Good morning, good afternoon, and good evening, everyone. And thank you for joining us for this first track of our IIoT World Days entitled IoT's Impact on the Utility and Oil and Gas Industries, brought to you by IIoT World and sponsored by Locent. I'm Greg Orloff, Senior Analyst and Chief Business Development Officer here at IIoT World. And on behalf of our co-founders, Lucian, Carolina, and our global team, thank you for joining us today. As the leading authority on industrial IoT, IIoT World is a digital media outlet bringing the latest industrial Internet of Things, virtual conferences, and content to a global community of 200,000 decision makers and influencers across the manufacturing, energy, smart infrastructure, cities, and building sectors. IIoT World focuses on delivering daily intelligence on the Internet of Things, artificial intelligence, augmented reality, predictive analytics, digital disruption, cybersecurity, and machine learning. We're monitoring the online channels today, so feel free to send your questions. You can do so here in the Q&A section of the Zoom platform or via social channels using hashtag IIoT World Days. That's IIoT WORLD DAYS. Today, our panelists are poised to provide insights through multiple case studies and real-world examples of how the Internet of Things is enabling digital transformation to take place in several different realms of the energy sector. Our first session, entitled Data Science in the Hands of Operators and Maintenance Teams, will be presented by Mr. Ty Burridge Oakland, Managing Director of Cognitive Business Limited. Ty started the business with his fellow co-founders to provide machine learning solutions focused on industrial IoT to operations and maintenance teams to optimize plant performance. Before starting Cognitive, Ty held critical roles with E.ON and Uniper, where he developed and led the global technology deployment for advanced condition monitoring and predictive maintenance solutions. So looking forward to hearing this first kickoff session. Ty, the floor is yours.
Excellent. Okay, so today we're going to discuss machine learning and operations and maintenance and how the power of industrial Internet of Things data can really drive forwards the power generation sector and how actually where the power of the data is used is vitally important. So what is industrial Internet of Things data? Well, to me, industrial Internet of Things data looks like this. This is data from an open source wind farm provided by Engie. Yeah, anyone can basically access this data, not necessarily this platform, but they can see this data. The data is very noisy, messy, but there are some real key insights hidden away that are really powerful and can provide significant value back to the owners of that data, operations and maintenance staff. So within power generation, where I tend to focus, that can include, this is specifically wind turbines. These are onshore wind turbines, but it could be offshore wind turbines, or conventional fossil plant, like a combined cycle gas turbine, coal-fired plant, energy from waste plant, maybe moving into the sort of zero carbon concepts. But the data is always looks like this. It always looks kind of noisy. And this is the sort of level and granularity of data that I'm really interested in and my company focuses on. Over the years, working at E.ON and Uniper, as Greg said, this was always where we targeted our predictive maintenance approaches using advanced pattern recognition, or APR technologies known today. At Cognitive, we surveyed several plants, so including combined cycle gas turbine, coal, wind, but also moving out into other areas of gas, into gas distribution and gas treatment. And we found that there were fundamentally the same things happening across the supply chain. Every day, operations and maintenance teams are focused on delivering an operational plant, delivering electricity or delivering gas to the end user, which can obviously vary. Their goal is to respond to alarms that come from the control systems, to be able to analyze to some level the data that they have, but really it's to maintain the plant and increase the reliability or improve or maintain the reliability of the plant that they're operating. So I've worked with companies all the way from America to Russia, and even, you know, worked again with China and Japanese companies more recently. And what we see when we actually get down to a granular level, at the plant level, rather than maybe the fleet team level, is that often there are unresolved reliability issues that are basically hidden in the data, and they just take a little bit too long for the normal operations and maintenance processes to be able to be uncovered. And what's really interesting is that we've seen, obviously there's been an explosion in machine learning more recently, but that doesn't tend to be deployed at the site level. So you don't normally have site level engineering teams building machine learning models. You tend to keep that away in a central team. And what that kind of means is that the problems that are looked at in those central teams are a little bit bigger, and they're a little bit subtracted from the frontline operations where there is a substantial amount of value available. So what can machine learning do? Well, let's have a quick look and see. So this is a signal from an asset. It could be any asset, and it could be any signal in reality. It kind of goes up, it goes down. And so what can we do with machine learning with this signal? Well, interestingly, there's not lots and lots of things. There's only really two things, maybe three things that you can do with the kind of raw data. And in this case, we can use other signals and machine learning regression to be able to predict what the signal is going to do. And in fact, we can start looking at where these signals go wrong. So where there could be an issue developing on an asset. And from here, what we can see is machine learning giving you an indication there is an issue developing on this asset through this data. And we can then look a little bit further and say, well, how did you come up with that answer, machine learning? Well, the reality is that machine learning can use regression or some variant of regression to start predicting what a value can be and start looking at the deviations from those values. And you almost have to tell it, or you could use statistics to work out how far something has to deviate before it becomes a real problem. And if we continue to look into more depth and we want to really understand what machine learning is telling us, we can say, well, this line that we've now generated that's green underneath the blue is what machine learning thought our industrial Internet of Things data should be doing. And that deviation that you can see, which is zoomed fairly well in on this particular signal, was enough to trip this particular unit. So that deviation that's been picked up as a deviation from a prediction was enough to take the unit offline, and that's where you see that very sharp falling of the line in the middle of the page. So that didn't seem too difficult. How did we, what's the catch? How come this isn't everywhere? Why aren't we using these machine learning regressions everywhere on every signal? And why aren't we using them to basically detect the data root cause as explained by the data for every single issue that we ever have? And we really aren't doing that. We're often still using threshold alarms, which are nowhere near as accurate as that sort of analysis. And there's a really simple reason as to why we're still not doing this. And that's because it takes a hell of a lot of computational power to be able to perform analysis that's in-depth enough to pick out problems like that. And from an engineering team, they don't necessarily have the time to wait for that. So the particular issue we just looked at there was data sampled every 30 seconds over a 12-month period. And that data was kind of split up into 3 months of training data, if you know anything about machine learning, and then that model was used to analyze the rest of the 12 months data. There were multiple signals involved in that prediction, so that wasn't a single signal prediction, it was a 10 signal prediction. And the number of comparisons that actually required for that sort of, if you were to brute force it, would be 2.5 trillion. For most applications of machine learning, just to look at that one problem, which was worth a significant amount of money, that's just too long. It takes either a highly skilled data scientist, or you have to downsample or average or interpolate or extrapolate data to such an extent that potentially you lose the granularity of that particular type of problem. And so it becomes very difficult to actually extract the value because of purely the time it takes for the analysis. So I analyze it. So let's look. So here's a few different case studies, and I won't specifically go into massive amounts of detail in each one of these, but purely just to say, this first case study is for pressure reduction system governor valves across a gas distribution system. And a small deviation that was identified in here was enough to mitigate a risk of about £7 million in fines through a year period. That's the kind of those small deviations that you can pick out. That's where that sort of value is and can be, specifically in gas distribution. So very important to keep the gas flowing, and when that gas ceases to flow, there are severe penalties for operators. Another downstream gas distribution opportunity, much smaller, but again, if you can perform the analysis fast enough, £20,000 for a faux filter issue. So in this particular case, teams were being sent out into remote locations to swap out filters on a system where the system was actually under pressured, and it wasn't a filter issue at all, but the filter alarm on the control system was firing, so teams were just being sent. That was costing around £20,000 per year. So again, just by using machine learning, by being able to analyze the data quickly enough and work out what has gone wrong, was worth about £20,000. So again, another kind of seemingly simple case study worth significantly more if you can do the analysis faster. This is a power generation application using a slightly different method. So this includes the other side of machine learning, which is classification, which is actually quite difficult to do on industrial Internet of Things data. But this particular one was worth probably up to about £200,000 in prevention of consequential damage, whereby a boiler had direct flow from a pump without protection of shut-off valves. This was very difficult to see under normal operation, but again, using machine learning, was able to predict the pattern of behavior of pressures upstream, downstream, and valve positions to be able to give a classification that enabled operators to understand almost instantly, within probably about 30 seconds of running a model, where their issue had been, and that issue had been ongoing for about 18 months. There we go. Further gas case study. So this particular gas case study is for gas processing, for gas treatment. The operator had a gas treatment plant that was removing, or I guess adjusting the quality of nitrogen output within their gas, and by enabling the operator to further understand their operational variables and control their operational variables using machine learning regression, we were able to show them how to mitigate an £8 million risk. They were constantly moving into the danger zone of their gas purity, and this was something that significantly helped them, as well as improving the usage of some cooling liquid nitrogen that they were using as well. So again, taking the machine learning and applying it directly on real data at the engineering end, and doing it quickly, we were able to provide our clients a very high and significant value case. In fact, and this is, so I've kind of spun through this presentation pretty quickly, but the overall outcome that we see specifically for power generation, I know there was a few gas distribution and gas treatment case studies in there. The value of being able to analyze data, and we're not necessarily talking about real-time analysis using machine learning here. We're talking about, bespoke modeling, but at the engineering, operations and maintenance end, is worth approximately £1 million per gigawatt per year. And we see this repeatedly, even with companies who are super advanced. So companies like E.ON and Uniper, where they have their real-time APR systems, which I put in for them, in essence, back when I worked there, they are still seeing significant value at the operations and maintenance ends for themselves. There we go. So that's the end of the presentation. Thank you very much for listening. My name's Ty. You can find me on LinkedIn. I'm probably the only Ty project in the world, so that's pretty straightforward. And I work at Cognitive Business. Thank you.
Thank you, Ty. It's some pretty staggering numbers when you start to look at the value that's created there through digitalization efforts. Thank you for sharing. Our next session is creating a more resourceful world, IoT's impact on the utility industry, and will be co-presented by Eric Toperzer and Craig Baldwin. Eric is the Senior Partner Manager at Itron, and in his role, Eric's worked with Itron's developer community to enable new IoT sensors and devices that leverage Itron's wireless technology. Eric worked with New Cosmos to deliver the industry's first battery-powered wireless methane detector that is being rolled out across the Con Ed service territory. Craig is the Partnership Director at Lowson, where he manages channel and technology relationships, as well as key strategic partners such as Verizon, Singtel, Cree, and Itron, to ensure a mutually beneficial go-to-market strategy is achieved. Eric, can't wait to hear what you have to say. The floor is now yours.
Thank you, Greg. Can you hear me?
Yep, I hear you fine.
Okay. See if I can get these slides to advance. Yeah, you need to pass the control over.
I think you've got it right down there. You should be able to click the little arrow. There we go.
Yeah, thanks for having me. My name's Eric Toperzer, and I'm with Itron's Technology Enablement Group. Our group works with all types of partners that integrate Itron communications technology into all types of different devices. Itron is a world leader of the Internet of Things. We have a long history of delivering scalable network solutions to utility customers worldwide. AMI, which is really the first advanced metering infrastructure, is one of the first types of IoT applications. It's essentially meter to cache, but a lot of the other things are happening on top of that. Our technology enables highly reliable IPv6 networks to bring back consumption information, interval data, sensor information from all types of devices, electric, gas, water. We've got a portfolio of intelligent streetlights. It enables communications networks to build any smart city application. Itron views an ecosystem. It's really critical for the industry to move forward and for success. It's a combination of hardware, software, and sensor companies all coming together collectively to address a broad range of applications for smart cities and utility IoT. So Itron's been around for a long time. We do electric, gas, and water meters, and since that, I came from the Silver Spring acquisition. If you look at the number of meters that are out there, over 38 million today. There's connected streetlights. In other words, smart streetlights. It's the same communications technology across the portfolio of products. And we've got over 100 networks deployed today. These are private networks, right? So private utility and private city networks that enable people to add additional sensors onto this infrastructure, to deploy new products. The initial applications were very simple, meter to cache for metering technologies. There's voltage control. There's looking for leak and theft detection. And then from there, once that installed base is out there, people are expanding all these different types of applications to enable other different sensors that are available. So about 3.5 to 4 years ago, I worked with Silver Spring to build the developer program. And it's available today. You can go to developer.itron.com and you can look at what's available. You can do everything from enroll, you can get a developer kit, you can buy it online. There's communities. We've got over 1,000 members of our developer portal today. There's all types of applications that are available. There are reference applications that enable you to look at the technology, and it's the exact same technology that will be available in these networks today. So if you can build an application using our developer kits, you can take that to one of our customers, demonstrate it, and then very, very rapidly prototype it and put it onto their network. What we're seeing today is the applications are really endless. We do lots of things for our community. If we have a utility that's looking for a specific device, we'll take an RFP or an RFI that they have and we'll broadcast it to our developer community. So it's really a meeting place where we take needs and basically developers that can enable different applications based on their expertise, and we bring them together. So whether it's a continuously powered device like a meter or a battery powered device, we have applications that can fit both. Some are simply monitoring devices for water level or anti-tamper, where others are advanced telemetry and for mission critical application. This is some examples that we're seeing today that people are building applications for. Some of those are for smart cities. Some of them are for the public power market. Essentially, cities utilities, and they could be electric, gas, or water. They're in waste management. They're in public safety. There's all types of applications that enable people to stay safe and stay more effective.
Craig, you're breaking up. It may be easier if you dial in. I just put in a chat the phone numbers. You can dial in and map it to the appropriate meeting number.
Is that any better?
Yes, now it is.
Okay, great. So one of the partners that we worked with, started several years ago, was working with Con Edison, who was looking for a solution to natural gas detection. They had aging infrastructure in the city of Manhattan, and they were looking to avoid any additional issues that they had. To give you an idea how bad the problem is, about every 8 minutes, Con Ed answers a call about natural gas in terms of a leak, and their target is to respond within 30 minutes. And really, essentially, a fifth of those calls require repair of some way, shape, or form. So they were looking for a device that would enable them to detect natural gas. They needed to be battery powered, and they were looking for a long life product. And they were looking for a device that had 0 false positives, because if you have a false positive, fire trucks are rolling. The initial pilot for Con Ed was 9,000 units, and today they're expanding across their entire service territory. The device itself is built with a company out of Osaka, Japan, and it's a company called New Cosmos. And essentially, it's an intelligent methane detection device that senses 10% LEL. So it's about the size of a smoke detector. It's installed at the service entry point within the house, and it uses a hot wire MEMS technology to detect gas, within the house. And so some of these leaks propagate along the pipe coming into the house. Con Ed owns up to and including the meter. So the device itself, similar to a smoke detector, it has a audible, visual, and a wireless alert. The wireless alert goes across the available within Con Ed. There's daily health checks and there's a runtime indicator so you can understand when the device will need to be replaced, and they collect all this information within the back office. The device is very, very sensitive. It only detects natural gas. So if there are any household chemicals or anything else in the location, it is totally immune to any other types of the device. And within the first 12 months of deployment, they detected over 100 leaks. Some of those were very small. They call them fuzz leaks. But leaks go from bad to worse. And the device was very effective in making that happen. So right now we work with Locent to develop a dashboard, essentially to be able to present this data, and we're using it today within our internal testing. We have other customer pilots that we're using it, and now I'll hand it over to Craig so he can introduce you to Locent and take a look at the dashboard.
Awesome. Thank you, Eric. Greg, do you mind just advancing through the slides on my behalf? Is that okay?
Yeah, I can do it.
Certainly, not a problem. You can,
Awesome. We'll just start right here. Thank you, Greg. And thanks, Eric. So, hello, everyone. This is Craig Baldwin. I work at a company called Locent. We are an enterprise IoT platform company based in Cincinnati, Ohio. And we actually had the privilege to work with Eric and his team over the last 2 years, give or take, to support for visualization around the methane detection solution for some of their pilot customers. So as Eric showed you, the methane detection sensor is a perfect example of how IoT is impacting the utility and energy industry, In the case of Itron, they already provide large-scale infrastructure, network infrastructure to their customers, primarily utilities. And when you deploy that type of network infrastructure, you quickly realize it can be used for other things than meter monitoring, whether that's electrical or gas. And so in the case of Con Edison, as Eric detailed, they were able to take advantage of that existing network and really just support costs for a new sensor with the proper communication module to then provide a ton of value to their customers. In the case of the methane detection application itself, we're talking about, in some cases, the difference between life and death. If you're able to monitor and find a methane detection or natural gas leak soon enough, you can change someone's life. And I think that's a really, really awesome example. And we've just been lucky to play a very, very small role in that. Greg, do you mind going to the next slide for me? So I want to talk a little bit about Locent, just to detail how we were able to play a role and how we think this type of technology can add value to utilities, and frankly already is today. So, our platform, quote unquote, is really made up of a set of foundational components. we break those up into 5 foundational components. And to be honest with you, whether you use LoSANT or not, you could use Microsoft or AWS, whatever your preference might be, it doesn't change the fact that we think these particular components are incredibly important to deliver a full stack IoT application. And you can drop this in any industry, whether that's manufacturing, industrial equipment monitoring, or in this case, the utility industry. So the first component is edge compute. That's actually taking some of our workflow capability, running it within a local network or at the gateway layer. This is really great for data extraction from industrial based applications where perhaps there are not machines that can talk directly to the internet, but have to use industrial protocols like Modbus, CAN bus, OPC UA. Devices and data sources is really the commodity layer of what we provide. This is really structuring the data and architecting your devices within the network, within the LoSANT system. The important piece here is using a system like LoSANT or any other is really about normalizing data, right? It's about capturing information from different sources, whether that be device or network, and normalizing it in a central location. So the application developer, the solution developer who's working with it doesn't have to do anything extra to build their final presentation layer. When we get into data visualization, this is really about dashboarding information. This is about moving quickly to validate the types of information you're seeing. This is typically used in an internal operations use case. And then the 2 pieces of secret sauce that we provide, to be honest with you, that we think are special in the industry is our visual workflow engine, which is really where all the logic of a solution or application would occur. This is a very low to no code environment. And then end user experiences is actually taking all of this data, whether it came from an edge compute device, a sensor connected directly to the internet, applying your logic to it, and then now finally presenting it in that application layer with your own URL, your own brand, really powering a multi-tenant application. And we think, the combination of these 5 components enables just about anyone to deliver this type of solution. And I'm going to show you an example here pretty soon as it relates to the methane detection application. Greg, do you mind going to the next slide, please? Thank you. So just to prove to you that we're not some small company from Cincinnati, Ohio, we do work with a lot of large customers and partners. As Greg talked about before, I work in our partnership group, and we support many companies in sort of the network operator space. And frankly, I'd probably throw Itron in there a little bit to really be the backbone of their IoT applications and strategies. So you may not see the LoSANT brand in front of you as an end user, but there's a good chance that we could be powering the application that you're using if it's coming from one of these customers, and then many more that we have, which unfortunately we don't state publicly. Next slide, please. So within the ecosystem that I work with and I manage, I think Greg mentioned this in the setup, we do have a traditional channel part to our partner program. This is solution providers. So if you're an engineering firm or a web development firm or a system integrator and you think this looks interesting, by all means, please visit losant.com/partners and reach out for more information. We would love to chat with you. We think that we're providing really great revenue generating opportunities for the partners in our ecosystem. We have technology partners. So, I think what's really cool about this session is you're hearing from really 3 different parts of the IoT stack today, right? And they're depending on how you look at it, there are many parts to the stack, but in the simplest form, there's a device, there's the network, and then there's a software. In the case of TIE, we're also talking about advanced analytics, which probably in itself should be and is its own practice. But what we have found is you have to bring together multiple vendors to bring about a powerful solution, whether that's for a customer, in this case for the utility industry, because there really is no one company that has expertise and can source the solution from the end device to the software to the advanced analytics. So this is why it's critical for us to partner with sensor companies, network companies, Itron being an example. And then, you know, the last one is strategic partners. These are companies we work with in very, I hate to say strategic ways, but essentially we are working with them on their strategies. They're leveraging our technology, and they're using our technology to resell or sell their own branded applications. And these are really the big companies. These are Itron, these are Singtel, Verizon, Hewlett Packard Enterprise, et cetera. Next slide, please, Greg. All right, so let's talk about the methane detection solution. I think that's probably the most interesting one. Next slide real quickly for me, Greg, apologize. So what you see in front of you is what we would consider an end user experience, okay? That is just a fancy LoSANT way of saying an application that has its own brand, its own look and feel, has login, user authentication, the whole 9 yards. And in this case, actually has multi-tenancy. So if I am a user from Itron, I may have admin privileges and I can see all of the methane detectors that are out there today. But if I'm from a individual utility, so in my part of the world, that means like a Duke Energy, maybe I only see Duke Energy devices. So what is really, really cool about this is, you know, Eric and I went from just a couple simple conversations over 2 years ago, and really within a matter of a couple weeks, we were able to integrate with the Itron network technology. In the early days, this was just via HTTP and via webhooks. Now we're actually taking a more advanced MQTT subscription model. But a lot of those tools to do that for us are right out of the box. And so it's really just about configuring those integrations and making sure they work properly. So that's one step in this journey that you have to fulfill that's really critical. And we were able to do that really within about a day. Now, once you have that information coming in, you guys saw, I saw earlier, or talked about earlier, excuse me, devices and data sources. Now I'm really codifying that device information and I'm showing what is it about that device I care about. In the case of the methane detection application with Itron and Eric, of course I care about those LEL levels, or really what I will get from them is an alert that says, hey, actually we have discovered an issue and we need to act very quickly. And so we're basically providing about as close as we can get, given the circumstances, to real-time monitoring of those alerts. But in addition to the alerts, you know, these are battery-powered devices that are sitting out in the field for years and years and years. And so they still need to report back and just say, hey, everything's working, everything's okay. So these devices are reporting health checks several times a day, and we're capturing that information as well. So, you know, this is the type of thing that traditionally might be presented in a CSV download, and someone might have to run a report on it every single day and then do a check. That is a pretty reactive measure, to be honest with you. What we have here is a system which is pretty close to real time. It is much more proactive. And in our case, the sample application you see in front of you was built in just a couple weeks, right? And so that's the value that we bring to the table for many large enterprises, but especially for some of the customers that Itron has that wants to take advantage of this methane detection application. And to take this a step further about, you know, what does this mean for the utility industry and what does IoT represent? I got to go back to what I mentioned before, which is a lot of these utilities, especially, you know, I'm a little biased, we're based in the States. So we have these gigantic utilities around the US who have invested a lot of money in network infrastructure. And they want to use that network infrastructure to its fullest capability, right? Well, what's so great about that is now they can add on many different devices that are essentially point solutions for them. This is a perfect example of that. Maybe it's a wastewater management solution, maybe it's a flood management solution, maybe it's shotgun detection. There are several different ways that you can bring in information from different sensors into that same network. Now, the tricky part of that is you're not always using the same network, but let's assume you are. You still have different devices that have different payload types and different information, which we might call attributes that you care about, right? The information I want from a gunshot detection application is going to be different than that I'm receiving from a methane detection application. And so what we are able to do is normalize that information across a wide breadth. And that's the challenge we see today as it relates to IoT, among other things, for large utilities is, hey, we really want to solve a bunch of problems for our customers. We think the value is there. However, how do we integrate this data? How do we manage this data? How do we visualize this data? That's the really tricky part, because there aren't a lot of systems out there that are flexible enough to facilitate this type of activity. Many of the systems that are being used today are purpose-built, right? They were really built for the meter management and monitoring the data coming off the meters. If you try to shove other devices into those types of systems, you're not going to get the same result. And so we think that's where utilities of the future really are going. We think Itron is playing a leading role in that story, not only by the network infrastructure they provide, but the solution, really their ecosystem of partners who are bringing forth these sensor solutions that can solve all of these very niche problems that utilities have, especially depending upon their geographic region. And then, you know, we want to play a part in that in providing that visualization layer, because without the screen in front of the end user, how can I make the proper decision with that information? How can I pass that information on to someone out in the field who's operational? How can they get that notification right away? It sounds simple, and I think it sounds simple to a lot of people who've been in the software industry for a long time, but when you're talking about the size and the scale and the, in some cases, the age of these devices and these networks, it is very, very, very difficult and very complex. And so if we do our job properly, we will drastically reduce the complexity as a part of that overall equation. Greg, you mind going to the next slide, please? So this is just a closer up example, and to be honest with you, the next couple of slides are going to do the same thing. But what's cool about this particular example is you can see my list of devices on the left-hand side. So these are all methane detectors that are connected to the Itron application, which is powered by Losant. I see that one device in particular has sent me an alert that it has seen or detected a leak. I have one device which is inactive. That is to say, it has not been reporting. It's not been checking in with me. And then I have 15 other devices that are working fine and properly. So all that information for an end user is right here. And frankly, to do this without Losant would either require a custom build out of some kind, or just someone to manage a bunch of spreadsheets all day, every day. And so this is why we think this flexibility, you know, if you saw an application, to be honest, built by Verizon or Singtel or any of our customers and partners, it's going to look drastically different, right? What we are really providing are the tools that are powering these types of things. And if we do our job properly, we're going to do it in a much more efficient manner, and with a lot less overhead than building them from scratch, you know, on an Azure or AWS. It doesn't really matter, to be honest. So you'll see different views and different looks. But if we can get you to this type of experience within just a couple weeks, if we can get you to production in just a couple months, we think we've done our job. Greg, you can go through the next couple slides. Actually, you go to the next one as well. So to be honest, that's really all that we had to present. We wanted to really put a fine point on what Eric was able to share. At the end of the day, companies like Itron and Eric are truly the subject matter experts in this space and for their clients. We just think that our technology can help facilitate these types of experiences. And for someone like Ty, we hope that we can make the information that he needs to do the analysis he's doing much easier, right? If we can pull in data sources from many different places and make it easier to work with and run those really specific regression and machine learning models, then we think we've done our job. So with that, I thank everyone for their time. I think Greg's going to take some questions and perhaps ask a few questions of us as well.
Absolutely. Thank you, Eric. Thank you, Craig. There was a ton of information in that session. One of the points that just kind of struck a chord with me is the fundamental reason for the conversation we're having here. I mean, you've got an operator that's experiencing a reported leak every 8 minutes, every day in continuum. I mean, there's a huge opportunity there for delivering value. So thank you both for sharing that. I'd like to transition now to our Q&A portion of today's session, where we'll be entertaining the questions that everyone in the audience is submitting. And as a reminder, we have two options for sending in additional questions. You can use the Zoom tool right here in the Q&A section, or you can submit them via Twitter using hashtag IIoT World Days. And I see several of you have already, you're curious about the content from today's sessions. That will be available, as well as all the tracks from IIoT World Days over the next couple of days will be made available post-conference. So stay tuned for that. In the event that we don't have enough time to get through all the questions today, we'll also carry the conversation over to the social platforms, and we'll address them via Twitter once again using the hashtags that I mentioned. So that being said, let's jump into some of the input and questions that are coming out from you folks. I've got one here. This is for Ty. It says, how long did it take to ingest and begin analysis of data? And how long does it take to run a specific modeling or questioning?
Yeah, it's a really interesting question because it varies based on the company, in essence, that you're working with. And as the guys have just said there, it's all about the provision of access to data. So some companies, we're beginning to refer to them as data dark age companies. They basically still have their data captured in file systems on kind of networked just about servers. So getting data out of those sort of companies is pretty tricky. It can take a significant project to achieve. Once you've got the data, then it's up to you how you want to analyze that data, and depending on what sort of technologies and techniques you want to use, it can take different amounts of time. If you use a standard enterprise model for data science, whereby you have a data science team and the kind of cleaning, modeling, analyzing process takes place, that can take another couple of weeks. So for certain companies, it could take anywhere up to 6 weeks to do one piece of analysis. If, like the guys have just shown you, and we have some systems and kind of preferred methods of doing things that readily provide you with the data in the right format, our systems that we use enable most of those analysis that I've just shown, including some of the significant analysis. Like, some of those were over 7 to 10 years worth of analysis, which is important for industrial devices. We can do that in about 10 minutes. So really, as I was trying to hint throughout the presentation, time is important, speed is important. To get the value out of these use cases, it really does make a difference having readily accessible data and the ability to then understand how to process that data and having the right tools for the job. I hope that is a good answer.
If not, Michael, please chime back in and we're happy to elaborate. Thank you, Ty. Hugo's got an interesting question, and I'll throw this at probably Eric or Craig. It says, gas methane detection autonomous, what type of communications mediums are used? He says he's making the assumption based on battery that it's not GPRS or 3G, 4G. So could one of you expand on how these devices are talking to each other?
Yeah, the technology comes from the Silver Spring Networks technology, so it's 900 megahertz mesh. It's in the ISM band, so sub-gigahertz. The interesting thing is these devices, the methane detectors, we call them leaf nodes. So they join the mesh, but they don't participate in the mesh. So the meter-based infrastructure is mesh-based communication that provides very resilient technology. These devices are battery powered and they're sleepy devices. So 3 times a day they wake up and they send a health check. If the devices do sense a methane in any location, what they'll do is they will send, and they are UDP, it is IPv6, UDP, and it follows the WISUN standard. So it will continue to broadcast messages every 30 seconds until they're physically reset. So if there's an alarm, the devices will continue to alarm over time. And at that point, you don't really care about battery technology. But the devices will last over 6 years on a single battery.
Wow. So that's a pretty good lifespan then.
Yep.
Another quick, this is from Isaiah. He's saying, since the devices are performing critical safety functions, have they followed secure by design standards such as ISA or IEC 62443, 41, and 42? So any insights you can share on the safety critical nature of the devices?
Yeah. So the devices, you can actually go to the New Cosmos website and you can download the spec sheet on it. And there are specific North American standards that are required. And I believe it's a UL certification for methane detection. And I believe it's 1594. I believe that's what it is. But you can actually go to New Cosmos USA and download the specifications. I think the ones that you've referenced are European. So they're a little bit different.
Okay. Gotcha. Thank you. Now, Robert's got a question. How does Itron authenticate devices and encrypt data for the methane detection devices? He's curious if you're using certificates or tokens or some other type of methodology.
Yeah, great question. So if you look at the history of Silver Spring Networks, you take one large utility of 5 million meters. That's the cash register for a utility. When a device comes online, it has a unique identifier, which is a MAC address. We take that MAC address and we bind it with the serial number of the device. It is loaded into essentially something called the DMS, the Device Management Server. When that device comes online, the first thing it does is it finds its closest peer. And it does, basically, it does an exchange of certificates. And once it does that, it is locked onto the network. So the very first thing it does is has secure association with a peer member. The next thing that it does is it gets timing information from the network. And then the third thing it does is it goes through the network, propagating through a gateway, and then authenticates into the device management server. The device management server sends it back an acknowledgement, and every subsequent message after that is we call it a bubble up message. It's sent through a different path. So once it's authenticated, it will send the information to a specific location.
Okay. Yeah, thank you. So Craig, we got a question for you from Paul. It says, what difference do you see between LoRaN networks and the Itron WeSun network?
Yeah, that's a great question. And honestly, Eric could probably add some value there too. I think that they bring different things to the table. They have different requirements. Ultimately, they are going to have probably a little bit different security profiles as well. And, I don't want to speak for Eric on this, but I imagine the LoRaWAN technology was not as prominent when Silver Spring was developing this mesh technology that was WiSun based. I think they would argue that WiSun based network system is probably the best one for this particular type of application in the utility industry, and that being really a core networking infrastructure for any type of utility and metering monitoring. So, I see the LoRa piece coming up more globally. You could put, in some cases, Sigfox right alongside that, and that's its own discussion over cocktails, I imagine, for many of the people on the call. But it comes down to a number of different variables. I think a lot of the, at the end of the day, the utility themselves is going to decide what's the best network they can get for the particular cost. That's going to play a big role in this. But I think looking back at Silver Spring's tradition, it was really about developing that network technology as a core differentiator. And so, they made their bet years ago. They continue to live up to that and continue to provide that. But under the hood, you can get similar results. You're just going to do it different ways, if I had to guess.
Gotcha. Okay, well, thanks for the insight. Another interesting question. How does LoScent deal with getting data from areas with limited connectivity? Are you only focusing on low data volume applications in these areas, or do you have any sort of edge processing capabilities?
That is a wonderful question. We have customers who are using LoScent in very remote areas. So, you know, one in particular who monitors water pumps in the outback in Australia. And in order to consistently extract that information from the device, in this case, the water pump itself, to maintain record of that information, and then to eventually get it to the cloud for additional visualization, that edge compute piece is huge. Okay, and that's when I showed those 5 components, that was one of those components. In our world, what that is essentially an open runtime that is shipped as a Docker container down to a gateway device. So, you know, name your brand of edge gateway device that you like. And once that's there, you're now running basically a slimmed down version of our LoScent cloud, especially the workflow engine locally. And we will, on whatever frequency you set, collect that information and store it locally. And if connectivity goes out, it will continue to store. When connectivity comes back, it will then buffer up to the cloud. So we absolutely agree. It's very, very, very important to, especially in industrial applications, maintain the integrity of that data when you start collecting it. And so that edge compute piece is really a must-have if you're going to do that type of thing, even in areas with good coverage, because as we all know, that coverage can still drop. And so I think that edge compute piece is really a security blanket for the overall application.
No, interesting examples. You guys are involved in a lot of different, I would call them fun applications. So thanks for sharing that one too.
Yeah.
Mahmoud would like to know, what's the added value of using IIoT and electric utility core, like power plants and high voltage transmission lines, instead of using a legacy SCADA system?
That's a great question. Ty, do you have any thoughts on that, given some of the data analysis work you do?
Yeah, no worries. So you can't get rid of the SCADA system or DCS. In essence, you need to protect the plant, the operations and control and protection work that's done by SCADA and DCS locally is one thing. You know, to really think about how IoT fits into any kind of business case is all about understanding that kind of use case at the end. You know, you don't want to be running a plant that could blow itself up in microseconds, whereby you're having to communicate the data up to the cloud and back down again to get a decision. That just doesn't make any sense. So having local protection, whether that be, you know, I guess you can do it sort of edge-based, but normally the way at power generation sites you do that is through the control system and kind of bringing together all the protection aspects of that as well, making sure that the plant can be tripped if necessary. You know, again, these are super real time. You know, we're not talking real time in terms of seconds. We're talking in terms of microseconds here. So it's a different kind of problem. In essence, most industrial Internet of Things data is data that is secondary or tertiary economy, as someone once told me, whereby you take the data away for another use, but primarily the data that you get in power generation comes from the control system, and maybe some additional things like vibration or chemistry, sensor technology, oil analysis technology, you know, all these other things that you can get data in real time from. You can bring them together in systems just outside of the control system. There's also various cybersecurity benefits of dealing with the data separately as well. In terms of whole high voltage transmission lines, you've got some real problems with that as well, because it's high frequency. If you're looking at some of the faults that you see, so therefore you need to have the right sort of devices measuring for those things. But the thing that you can do in the same way that Craig and Eric have mentioned is you can transmit the alarm data or the threshold breach data for analysis if it's close to the kind of normal operation. So it's not yet dangerous, and you can start sparking action, which is in essence, you know, the key to all of this is action. If you don't action your insights, then you don't actually ever get any value. So that's one of the ways that you can use this sort of data. That's the way I see the use of this data.
Yeah, one thing I would add is if you look at, you know, one of the most critical aspects of utilities, and that's monitoring high value assets. So whether it's a load tap changer or a substation gate or any other asset that may be out there, whether it's a single phase transformer that's, you know, serving a long feeder, it's really basic monitoring information. So you may be collecting the information, similar to a data available today. Maybe you're collecting the information on an hourly basis and you're sending it once a week. And it may be a battery powered device. So, you know, protecting those high value assets and understanding, you know, what's out there and how to prioritize your efforts is another, you know, thing that we see. And that's driven by a much lower price point than which data, where you've got polling of, a smaller subset of devices.
Well, thank you both for elaborating on that. Hopefully that addresses your point. Again, interesting, I've been waiting for this question to pop up now, and Paul sent something in along these lines. Is how vulnerable are these devices to cyber attack and use as a launch point back into the network?
Yeah, it's from a security standpoint, the technology we have is multi-tiered security. So, you know, we're secure at the MAC layer, we're secure at the IP layer, we're secure at the application layer. You know, multi-tiered security is an absolute must. These are private networks, and they are like, if you look at a utility that says, you know, maybe they've got 5 million electric meters, they've got, you know, $100 per month per customer per meter. You're looking at tens of billions of dollars going across their network, and that's why we keep it secure. Again, the most important thing, and there are a couple of security white papers out there. If you Google AMI security and Silver Spring networks, you can pull up some of the white papers that have been established to talk about multi-tiered security.
Got it. Okay, you're breaking up a little bit there. I think at the end there. Could you just reiterate that last point?
Yeah, I said the most important thing is it's tiered security at every layer of the OSI stack. So it's at the MAC layer, it's the IP layer, and it's at the application layer.
Got it. Thank you. Any insights on the adoption rates of these technologies in various industries? I know we're obviously talking about utility and gas detection, but Praveen's curious about that. I don't know if you have any insight on that, Ty.
So I can only really talk about the adoption of kind of machine learning and capturing data and collecting data. For the industries that I've worked in, as I said, that there are some of these kind of data dark age companies who readily they use their SCADA system and that's it, and the data basically gets binned / archived every 30 days or a year, and it never really gets looked at again. So some companies really don't do anything with their data, and they just plod along, and they're starting to see now, as they're recognizing the opportunities for collecting data at a lower cost, there's more chance to do analysis, and then all of a sudden they're blooming into this ability to use more advanced techniques to get the value out of their data they didn't even know was there. And then you've got companies who are providing real-time, in inverted commas, machine learning support from kind of like Pi, Aussies off Pi, if anyone's ever come across that, historian type devices. That's there's significant value, and a lot of companies are now recognizing that above and beyond standard condition monitoring, predictive maintenance. There's also performance optimization opportunities whereby people are realizing that they can in real time-ish control their plant, or at least get operational support from machine learning to add, depending on what industry you're in, it could be millions of pounds a day or millions of pounds a year. It really does depend on the value of your product that you're producing and how much people are prepared to pay, and margins, all that sort of thing. So yeah, I'd say it really does depend, and it's pretty much different in every industry and in every company that you ever work with.
Okay, thank you. Anything to add on that one, Craig? Or
at the macro level, it's hard to say. I mean, obviously there's a lot of studies out there. We've been seeing a very steady uptick in the industrial and utility industries. To be honest with you, I think our current times with this pandemic are only accelerating that, the need for remote monitoring, but more so the need for change in maintenance habits is what's really driving this, reducing the cost of people coming to a home, checking on a machine, doing truck rolls, those types of things. That's where the cost savings comes from. We think those are the critical things to consider when calculating the ROI on your solution. And that first solution you roll out should pay for itself right away, even before you get into that additional value added stuff with, everything that Ty does around the machine learning and understanding how you can change overall habits and do predictive maintenance, or make predictions about the network or the equipment. So we see a very steady uptick. I've been in this industry for a while now, and I would say that there's been each and every year a step change in the level of adoption, because it's no longer a science project. It's a proven strategy from many companies in the industry, and that's not just utility, that's industrial as well.
I think the science project statement is very true for a lot of companies where they've historically used data in a very science project type way, and it's run very academically with no real focus on a value outcome. Whereas the concepts of using the secondary or tertiary economy concept, whereby the primary use of the data has intrinsic value, I think companies who've had that realization have seen the most value. And just to give E.ON a pat on the back, although they're now split into various other companies, E.ON had basically the entire global set of power stations connected together in 2000 and I'm going to say 11 or 12 through an AussieSoft Pi network, which was basically the beginning of the industrial Internet of Things. They even had industrial data coming back from all over the world, including companies that weren't E.ON, where they supported remotely for vibration data in the 90s across 56K modems. So they really were spearheading the use of data and analysis and high power machine learning or statistical analysis combinations, even back then in the late 90s, 2000s. So as I said, it really is very dependent on the company. Yeah, I just seen another question there about is it different in different countries? That's an interesting question. I wonder what everybody else has got to think about that.
Yeah, any insights on that front, gentlemen? I think it was Alistair's got a question along those lines. Following the technology adoption, do you see differences between America, Europe, Asia?
Yeah, one thing I would say is what these utilities look for is they look for scale, right? So if you look at what may hold them back, is they're a bit more conservative in the U.S. Because when they roll something out, it's got to work. So look at the product that came out of our developer program, which was the methane detector. Once that product was deployed in the Con Ed footprint, there's probably a half dozen other devices that they're looking to deploy in their infrastructure because they know the technology works, the communications works, the back-end systems work. So I think the adoption is all about product maturity and product availability. And that's what we're seeing today. The U.S. is a CapEx-based utility, for the IOUs. So that's a little bit than what happens in, overseas. So there's probably some different buying trends, and in the US, they'd rather own their own capital versus having operational expense.
Got it. Well, we've got time for probably one more question, and I want to take it out to a little bit, maybe more of a macro perspective. John posed one earlier. Where do you see the talent coming from to solve, future problems in industrial IoT? Is it an IT source, OT source, something else? So I'd like to hear each of your perspectives on the need and some of the sources for talent, if you could.
I'll take a crack just for the Losan side of things, because I feel like we've seen a lot of interesting habits develop. Look, the theme of this, again, is it takes different skill sets to execute on the overall solution. Network engineers, operational subject matter experts, IT folks, software developers. There is no thing, at least in a credible way, that is an IoT engineer. And honestly, that's why we've developed the technology we have, just because we feel like it's our responsibility to lower the barrier to entry for a lot of these folks, particularly on the OT side, or have the true subject matter expertise, but also have an engineering background, even if that's not a software engineering background, and can pick up our tools and use them, because we think that's who's going to get the most value out of them over the longer term. But it's incredibly difficult to find someone with these skill sets, and a lot of them are nascent, right? I mean, we're in the early days of bringing these things together and figuring out what they mean. So, we see a lot of folks from the industrial world and utility world who pick up their pens and say, hey, I've been interested in this software thing for a long time. I know networks really well, or I know devices really well. I know the operational application really well, and I want to see if I can pick up the software side of things. At the end of the day, I think there'll still be multiple folks that are in the overall solution, but I think the people who are positioned to drive the best value are the subject matter experts to help with the overall architecture, and in some cases the implementation, especially on the software side.
Great insight. Thank you, Craig, for sharing that. Well, I think that takes us to probably a good stopping point. And I know we didn't get to the myriad of other questions that are in here, but please rest assured we will circle back, and someone either from the organizations we have here, Craig, Eric, or Ty, will circle back with you, or IoT World will publish something post-event with a compilation. So thank you for taking the time to join us, and thank you, Ty, Eric, and Craig, for sharing your expertise with us. Some outstanding content here. I truly enjoyed it at a personal level, and based off the attendance here, I think the audience did as well. Don't want to speak for them, but we're going to give you some good comments. And it would not be possible to run this virtual conference without our sponsors. So special thanks to Losan for making this track a reality. And please enjoy the rest of your sessions throughout the balance of the day and tomorrow, and stay tuned for following future IIoT World virtual conferences. We have one coming up September 3rd on machine learning and artificial intelligence in manufacturing, September 23rd on industrial IoT and manufacturing, and October 8th for Industrial Cybersecurity Day. So more details to be provided in the upcoming months via our newsletter, so stay tuned on that front too. If you have a suggestion for a topic or otherwise, we always welcome feedback, so please drop us a message and let us know. And if you like what you heard today, we invite you to subscribe to our newsletter, YouTube channels, and follow us on Twitter at IIoT_world. This concludes our track for today. Thank you all for joining us.